Alright, we got two options here. We can either cheat and use this cutter here to come in and cut that edge away. Right here. And not have a very good control of the diameter wise. We're just going to cheat going back and forth and fudge it a little bit. And blow across the top, call it done. Or we can center up off the center of this and recut this thing actually on center with a big cutter. So there's two different ways of doing it. So in a job like this, where we're going to run a gasket on it, I think we're just going to rough this in, cheat. It'd be a lot quicker, easier. But we got to see how flat this is. There you go. Let's see what we got to work with here. So we have the same issue. I'm sure this thing's not going to be very flat, but we don't know. Okay, it's not quite big enough. Trying to be just on the edge here. 5, 0. I'm not touching here again. We got the same problem before. We're just starting to go back up again over there. 0, 0 all the way around. We catch a number right here where it starts to go in, and we're 5 up over here. So it's low on this side, but the problem is we can't jack it up on this side because it's a table. So what are we going to do to cheat? See, all this is out in the wind to clear all these dowels. So there's not much I can do to compensate for that. So let's see how far off we actually are. So we're at 0 over here. We're off a long ways. It's 13 thousandths to get to there. 2 down. 13, 15, 18 over here. Oh, it's really bad over there. It's 20. It's way over here. So it's almost a full dial. It was over here. So it's just like before. We got 20 thou of air in here for some reason. It's like the Harley cut this gasket surface is at the wrong angles. For whatever reason. Doesn't make sense why they would do that. You know, this stuff is cocked. It's not straight. It's consistent, so I don't think it's something that was, I think it's made that way. It was made about wrong. So that's going to make it hard to cut this anywhere near square because we have nothing to go by. So I think we're going to cheat even more.
You're saying it's high in the back right there, right?
Yes.
You don't think putting a strap back there, pulling it down?
No.
It's sitting flat right on the bed.
All we got to work with is this corner over here and this corner right here to tilt it up, and we got this right here. So I can cheat a little bit, which I'm going to try to do, but we're pretty far out. It's the same thing we were out before. 20 thou out. But it shouldn't be out this kind of numbers. These are all things that are supposed to be square. You know, supposed to be flat, basically. So I'm going to put this under here. So we're only hitting on this corner here, and this over here is all we're hitting on. Okay. Pressure back on this side. Good enough to hold it. So 0. Pretty close to 0 over there now.
Oh, it's going down.
Have to shoot the camera over to see. Yeah, it's 5. It's going up. 5, 5, 0, 0, 0, 0, 0. It's going up right here. We're going up to 5.
It was up 20 before, right?
Way over there around 5. The back side. It's over here, 5.
Yeah.
Okay.
Yeah.
It's 5 thou out now. So it's just like before, you put 20 thou shims in there, you within 5 thou. That means this thing's out of square by 20 thousandths.
So you're gonna only cut that one.
Which is way the hell out, see? See, that's pretty even all the way around. See, that's only a couple thou from here all the way over to here. That's pretty good. When you hit here to here, it's where it goes up. So I can make this worse by tightening, but we're even right now. Even to here, we're good to 0, 0. Right here's where it goes up. From here to here is high. All this hill is low. Now that's where you weld it, so this is probably well stepped up a little bit, maybe, would be my guess. But the problem is we have the same air on both sides. So, you know, you got a broken primer, you don't know what's happened to it, if it's been twisted, you know, what caused it to break. You know, they don't just break for no reason. So something's definitely changed.
So in this case, it's best not to cut the whole surface in, just to take that off and hope that gasket's going to seal it.
I can cut it right now, but this is not flat to here because we're 20,000 here on this side. This whole thing's up like this.
Oh, so that's what I mean. But
So even though this is flat here, this is cocked over here. Now if I put this thing back flat, I don't know how even this surface was either. This surface should be made flat to this surface, not the other way around. Because this main bearing holes, all these holes here should be square to this surface and this surface. Because that's what bolts against the motor and the tranny. This is just a stupid cover. It doesn't matter if it's out of whack. The problem is we're trying to use this surface here to make this surface good. So right now this surface here to be square, which is pretty square. From here all the way around to here, we're only moving a couple, 2, 3 thou. That's a lot of area. And right here's our air problem, right here. And that could be where it'll be when you mock up and you welded it. It worked at that much. But the problem is this whole surface is not square to this surface here. Well, I don't know. I didn't put a... I haven't actually measured this to see if this was square from here to here. It might be, because it might, like I said, this whole surface here might be off by that 20 thou. My guess is this is all cut wrong. These are probably pretty close if you actually measured them. Would be my guess. But so when you're doing this stuff, you have no idea what's what. How things move when you weld them, how good you did a job. It's all a relative phrase. So what we're going to do is we're going to go ahead and cut this thing. Just get some marks, tattletales where I'm at. I'm going to mark this one down in here. This here is just a clearance cut on this. Oh, it's already in there. Duh. Now the problem with this is I'm going to hit over here, so I can't get too far over. I think I'll just come in this way. Okay. Clunk. Okay. Switch sides. Gotta be over here where I can see. Okay, I'm hitting on the far side over there right now. Right now I'm hitting right here on this edge. I'm not hitting here. I'm hitting here. So what I'm thinking is we know this side here is high over here. Mark this again so I know I'm not hitting on this. So somewhere about here, and see this cover was loose. See how it's all worn away right here? Yeah. This whole primary was loose. You can see all the wear marks. So if I recut this surface over in here, and cut it from square from here to here, and that takes away this mismatch from the welding. I just clean the whole surface off because it only 5 thou tall. So I just got to go over and touch over here and see how low it is on that side and figure out how low it is on this side. So what we're going to do, I'm going to grab our 10 thou feeler gauge here, stick it in here. See, right now I don't have 10. So I'm going to go ahead and zero this out right now because that was where our cut was. Just back it up a little bit until I find what we got here. Okay, we're 2 thou under right now. Here. Okay. I'm going to go over here to the other side. Okay, we didn't hit. Good sign. Starting to hit right there. Okay, we're past 0. Okay, see we're over here, we're 3 past. So there's 5 thou between this side and this side. This side's low. Now that might come up a little bit if I loosen this up a little bit over here. The biggest thing is I can cut that whole surface there and be a little more even than we are right now. That's the key. So now that step that we had from here to here, I cut off. So now when you put an indicator on here, it should be pretty flat all the way around this thing now. Now I was cutting a little bit over here. I can't see it, but I heard it. So there's 1 thou or so I cut off right here, which is nothing really. So now this surface should be pretty flat and square. So when you pull it back on the bike, it's not going to try to re-break this. We took away that step that was in there. It also makes it a little better for sealing. So that's better. Now it's still lower through here because all this wear mark through here, but there's another few thou more down probably there. I don't want to cut the whole surface, but we just roughly that's where we're at. Okay, now we got to figure out how deep this is to cut to this surface here. I don't know how much of a step this is. So we're just going to go ahead and run it on down until I hit. It's hitting around 90, back up to 80. Yeah, it was hitting there. I couldn't feel it, but it was hitting. Okay, so now 80. All right. can't tell exactly where I'm hitting right now. So I gotta re-put the black mark in here so I can see it. I'm trying to get the cutter to match the radius of the part. Even though it's not 100%. You know, obviously this diameter and that don't match.
No.
But we should be close. So you bring this in, it should be pretty close. Give it 2 more thousandths. So I'm cutting that side but not this side. Yeah, quit cutting on the back side now. See, I was trying to cut this edge here, but it stopped cutting here. It was only higher right here. So right now there's a step between these two surfaces. It's coming across here. It's not very much. See that little edge right there? It's flush over on this side. Now if I cut deeper on the back side, it'll start cutting all the way around over to here. I can chase it around a little bit and kind of cheat. But I think we're probably close enough for that part. Okay, now this next one down here, I think this is just a clearance cut for the, let me just rough things in. I don't think it hits anything, but we'll go ahead and hit it anyway. So I'm going to cut that away so I can see it. So I got to figure out how low that one is. Missed it a little bit. Okay, where's it going to start hitting that? Finally. I missed it by 100 though. See, I can't see. Okay, we're still hitting on something. Could be off by that much. Jeez, it's 150 thousandths off.
You're hitting the radius, aren't you? The side?
No, I'm on the top. I keep taking material away, but I'm not. Where am I at? I can't tell where I'm at. Oh, I'm cutting back where I started. Dumbass. What is off by 150 thousandths? Jeez, moron. There we go. That's where I want to be at. There. See where I just cut right here?
Mm-hmm.
Okay, so that was on the 90. Back it off a couple thou. Move over this way a little bit. Alright. Okay, we're going to cut over here where I can't see the squat, but. Up a little bit. Alright, I cheated. So it's in there. I cut a little bit deeper probably than I needed to be, but it's just a clearance cut anyway, so it shouldn't be a problem. Alright. Alright, so now everything should bolt in like it's supposed to be. It's a pretty heavy file right here. Not really digging in heavy in any one place. Just knocking off high spots here and there with the file. So it's pretty flat. So that should work.
Don't feel any steps in it, so that's...
Yeah, well, there's a little bit in there, but not much. And that should be fine. You can almost put the O-ring in there and run it, but I think it would leak. It might seal the O-ring. You'd probably have to put some goop in it, but I would just use that flat gasket because it's all worn over here anyway. I think it'll be all right. You know, I knocked off that 5 thou from here to here, so that makes it more flat all the way, uniform all the way around. So you can now just deburr some of these edges a little bit, do a little light grinding, whatever else you need to do it. I think you got everything else pretty well ground anyway. That should have clearance. When you put the stator in there, the rotor, I'm sure it'll have a ton of clearance in here. I think it'll be fine. Let me pop it off so we look at it. Get out of the way so we don't hit it. It's just a matter of figuring out what's level and not level. It's a piece of junk, so then we do improve it. It's an improvement. Now this is where most of your unflatness is. Shins out of the way. Pretty flat. So grab the 1.5 thou feeler gauge out of the drawer there, top drawer, right down in front. That's it. So you hold this down with pressure, and you see where you can put it in here anywhere. There's your low spot. So across the bottom and the front it's low. It's right through here.
That gasket should make up for that. Okay.
Yeah. Yeah, it's 1.5 thou. That's nothing.
Yeah.
But you know, you can't really feel it, but it's there. So that's the area where I was doing my cutting. I didn't cut. I think right about here is my cut ended. I cut in about 1 thou out of it. But I'm still low all the way across here even when you flip it over. So, because these are, it hits over here and here, even though I cut a lot off that. Spode a little bit. That's why you put the gasket in there. I'm sure the case isn't very flat either. If this thing was loose like this, it'd probably eat the O-ring up on the case, the lip anyway. Anyway, that's pretty, not too bad. Now this over here, we got this low spot here, which you need to take off of the file if you want to a little bit, but the problem is it's not going to be very flat if you do it, because it's hitting here and here anyway. So once again, this is a pretty coarse file. I'm not pulling off that hard. Go move your hand, I'll poke you. There's nothing really sticking up way high as I'm going across. Yeah, it's taken almost all of that. Actually, you put a little bit of sealer right there, you'll be fine. If you want to make it close, you can put some JB weld right there, but it's very, very thin. And I don't know if it even stick. It's only, 3 or 4 thou thick probably at most, if even that much. So you see how we're catching up here on the edge. You can see what the undercut wire I did right there. We went in there a couple thou. That's still low. It's no different than what these low spots are. But all of that, the gasket will take up all of these gaps. So it's pretty flat. A few of these nicks over here, it's been heathenized by dropping. Couple high spots. Oh, pretty smooth. So these you need to round off these edges a little bit. Here's my rounding file. It's a little coarse though. Is that too coarse? We'll use some little dollar. So I don't want to cut myself, so even though it's a flat file, it'll still deburr. Cut yourself now. And the blood you save might be your own. Alright, over here. That's the factory unmachined surfaces, or undeburred surfaces. Makes the O-ring go on a lot easier if you use it.
So when you use that flat gasket, can you use an O-ring also?
No.
You got to use one of those.
I don't think you can. I haven't tried that one. I know the format material one, you can't. I'm assuming the James one you can't. You'd have to see if the gasket will go over the O-ring. I don't think there's enough room to go over the O-ring. I think it eliminates that O-ring lip.
Okay.
You'd have to compare it. I don't think there's room for it though. I tried it on that Texas bike I worked on, Chevrolet. I put it all together with trying to do the O-ring and the gasket, and it didn't fit. I had to take it all back apart, and you couldn't pull it down. It just wouldn't pull flat. It was binding. There just wasn't room for all the components in there. So I think it's one or the other. So we're going to use the gasket. That should take care of it.
All right.
All right, there you go. Here's how you fix a pile of crap. What fun. 3 hours later, right? At least.
Every video.
About 4 hours of work with the welding and everything?
Yeah.
Yeah, about 4 hours gone. Just about buys a new one if you could buy it. There you go. Close it up.